Hey guys, here we are, Chapter 11, Section 2. We're going to talk about water use management. How do we manage the water we have out there? Here is your essential question. How are dams and water diversion projects used to manage our freshwater resources? Something to think about as we dive into today's work. Now, water use management. If a water supply is polluted or overused, then everybody downstream gets affected by it. Most cities and towns are using water from easy to get surface fresh water. Rivers are just one of the big ones. And a shortage of fresh, clean water is one of the world's most pressing environmental problems right now. According to the WHO, over 1 billion people lack access to clean, reliable sources of fresh water. You and I in America, we don't think about it that much because we have water everywhere that's been piped in, it's been cleaned, it's been treated. But 1 billion people, 3 times the number of people living in the United States, do not have access to reliable, clean water. And this winds up causing an awful lot of sickness, disease, and death in the world. If you take a look at the graph I have back here, this is our global water use. Now, kind of going from the left to the right, North America, Latin America, Europe, Asia, Africa, Oceania, and the world. People often ask what's Oceania. That's an area right around Australia, New Zealand, Papua New Guinea, this area of Oceania. 3 main uses: residential, agricultural, and industrial. Now if you look across, the yellow is agricultural. By and far, worldwide use, most of it is going to agriculture. If you look at the 2 large industrial or technological centers of North America and Europe, well, our largest use is actually in industry. But residential, what you and I think of as using water, flushing the toilet, taking a bath, drinking water, is only about 10% of the total. It is the smallest amount used globally. Most of the fresh water used worldwide is to irrigate crops. Now, we have to have food, and the crops need a lot of water to grow. It's just the nature of things. But the patterns of water use are not the same everywhere. As we looked at in America, our industry tends to use more water than our agriculture, and some of that comes down to how we irrigate our crops. We use a little more efficient means. So industry is about 19%. So once again, residential around 10, industry around 20, leaving about 70% for crops. It's not the exact numbers, but if you kind of stick it in your head and the 10, 20, 70, you would be pretty spot on. So this other one back here is showing global water withdrawal and consumption. What we pull out of the wells, aquifers running with meters, versus consumption. It's hard to see all of the various lines that are there, but if you look at the map, it's a little easier. The line graph's harder to read. Asia obviously has the greatest withdrawal and consumption, but that's not surprising. Asia there is including both India and China, and India and China are 1 and 2 population. China right now, number 1, India an incredibly close second, and India is probably likely to pass China in the next few years. Then the United States is 3rd in terms of population. But then you get to Africa and South America, very, very low water consumption. Well, let's talk about residential water use. And this is a shocking difference from the world. Here in the United States, you and I, we average about 300 liters of water a day. 4 liters would equal a gallon, roughly, if you're thinking of it, about 300 liters a day. However, in India, the average person only uses about 41 liters of water a day. Much more water conservative in India than we are here in America. Our water is fairly cheap and accessible, and we tend to abuse it to a degree. We don't conserve it as well as we could. In the U.S., only about half of our residential water is actually used for activities inside the home, drinking, cooking, etc. A lot of it is outdoor, especially if you have a pool, if you're irrigating, if you're watering your lawn. So watering the lawn, washing cars, any kind of outdoor activity uses more than a half of our water outside. And really our watering of our lawns can be cut way down and almost completely out if we just monitor the types of plants and how and when we cut the grass. Now, there are definitely some ways that we could conserve that we're not currently doing. Now, water treatment. Most water must be made potable. Potable means suitable for drinking. In other words, you can't go out to your local creek or river, dip a glass, and drink it. Now, this is what we mean in lots of the world where they don't have access to clean and reliable water. That's literally what they're doing. They were going out to a local stream or lake, and they're dipping the water down, and that's what they're using in cooking and drinking, which is why it isn't safe. But most water has to be treated. Typically what we're doing is we're removing some things from it. Mercury, arsenic, lead, sometimes these are in the water supplies and they have to be removed before we drink it or we get sick. But these things can be found in polluted water where things are running off, but we do also find them in groundwater as well. But in any way, our water has to be treated. So it can have heavy elements like that, or what we might refer to as a poison, something you drink and would get you sick. They also have pathogens. Pathogens is going to be some sort of microorganism or a virus that would cause a disease. When my family and I lived in Nepal, there were lots of pathogens in the water. Giardia was kind of my nemesis, I would say. I would get Giardia several times a year because it was just in the water. And when we were out, we couldn't always control if our water had been treated or not, and it was just common to get it. So you can have poisons in the water like arsenic, lead, mercury. You could also have pathogens, typically a microorganism, bacteria, or some other form of bug, germ, pathogen that can get you sick. Also, pathogens are found in contaminated sewage or animal feces. And in America, our water is coming from something untreated, but in a lot of places, there are animals out on the roads and streets and everywhere, and they're pooping or peeing wherever they are. And that water runs off into the local streams, and then people are pulling water directly from the streams. So pathogens are just really common in lots of places of the world. One of the most common methods of making water potable includes both a physical and a chemical treatment. We will do a little bit of both. We'll physically filter out anything we can to trap it, and we'll get the water clean, and then we tend to treat that with chemicals. Here in the United States, by and large, we're treating ours with chlorine and fluoride. Chlorine to kill all the various wee beasties, and then fluoride to help keep our teeth nice and hard. Industry is accounting for about 19%. Once again, if you think 10, 20, 70, you're pretty solid. But about 19% is used in industry, and this is used in manufacturing goods. Let's take my shirt, for instance. In my shirt, well, we got to wash the wool, the sheet, and then we get all the wool off, and we might wash that again. And then we'll dye the wool, and we'll wash it to get the dyes out, and then we'll put it into the shirt, and then we wash the, you get the idea. Almost anything we're making, we're using lots of water. Now, also, one of the biggest ones is actually power plants. We have to cool the power plants. All power plants are located near a big water source because we're boiling water, so we need some water for that, to turn it into steam to spin our turbines. Well, this is generate massive amounts of heat, and we have to keep this whole thing cooled down. So we need to run in fresh, cool water around it. That water warms and heats up, and then we have to kind of dispose of it. Now, a lot of times we do this around rivers, and the water isn't getting dirty, it's just going around to cool it off, but it is heating it up. And we can talk about thermal pollution, if you will, because the water is coming down here, say at 70 degrees or 20 degrees, and we're dumping it back into the stream out there at 28 degrees. So the stream down here is much warmer, and this can affect wildlife, etc. But it takes a lot of water for our power plants, and is one of the big industrial users. Then we get to agriculture. Now the numbers are actually 67% in agriculture used around the world, and plants just require a lot of water. But as much as 80% of the water that we use to water our plants with winds up evaporating. Because how do we typically water plants, right? We sprinkle it on the top. Where does the water need to get to? Down into the roots. So all the water sitting on the plant evaporates off. A lot of the water just in the top of the ground evaporates off. And it's only the water that sinks all the way down that gets into the roots actually helps benefit the plant. So a lot of our agricultural or irrigation practices are not very efficient. Now in the United States and lots of Europe, we use some better irrigation systems, but they are expensive. Some of our high pressure overhead sprinklers are some of the most common, but they're not very efficient. The ones I have up here with the sprinkler head down on the bottom, even though it's overhead, this is low pressure. It's not putting as much water out, it's more of just what the plants need, and it's much more effective. The best forms of irrigation that we have are drip systems. This is where you have something down right on the ground or even under the ground, and water just slowly drips out into the soil. Very little of that is evaporated. So we have some good techniques to cut down on the water evaporation, so it's much more conservative, but it is expensive. Now people prefer to live in areas where the natural distribution of surface water is inadequate. This is just not uncommon at all. People choose to live over here even though there's not a really good water supply. So we have to divert water, such as dams and canals. Lots of areas in California are actually dependent on dams and water diversion projects from the Colorado River. Dams up the water so we get a reservoir, and then they can channel that water into the cities and towns where people live. So water management projects can have a lot of various goals. Just bring water into a dry area to make it habitable, make a reservoir for drinking water so that we know we have a reliable supply, and then also to take it off to areas where we grow crops. Once again, I'm sort of picking on California here, but a lot of the crops grow in regions that are traditionally very dry, but it was kind of flat, nice area, and now they'll pipe the water into it. But it takes a lot more water because the area is more traditionally dry, so there's more of the evaporation occurring. Now, in order to supply these dry regions with water, all or part of a river sometimes gets diverted into these canals, like you can see back here. It's just a nice little straight area taking it in. So that Colorado River is a glacial stream. In the springtime, the snows melt and the water pours in. And once again, we've dammed it a lot of places to pile that water up so we can store it and use it in the drier seasons. And as this river flows south, it is divided up to meet the needs of the 7 states that it goes into. And much of that river's water is diverted just for irrigation and drinking water, to the point that it tends to run dry before it ever makes it into the Gulf. There used to be a really rich estuary system and wetlands all around where the Colorado River's delta went into the sea, and that is virtually gone because we're draining all the water and it doesn't even make it down to the ocean anymore. So we talk about dams and reservoirs. A dam, well, as we look at the picture back here, that's the physical cement structure blocking the river from flowing downstream. Then the body of water behind it we call a reservoir. Looks like a lake, it's just a man-made lake, if you will, referred to as a reservoir. Now, water from the reservoir can be used for flood control, right? We're keeping it from going downstream. We do it in released measures. It's used for drinking water, irrigation, recreation, people go out on boats on it, and for industry, hydroelectric dams. We rarely build a dam that we don't hook hydroelectricity up, because once again, the water spills down the dam, at the bottom it spins the turbine, and we get very cheap electricity. We don't have to burn anything, so there's no pollution from it, and the water keeps on running, it keeps spinning that turbine. So we get some cheap, reliable energy. Now it's expensive to build the dam and the plant, obviously, but once it's built, we get pretty reliable, clean energy. About 20% of the world's energy currently is coming from hydroelectric. Now, there's only certain places you can build hydroelectric because you kind of need mountains and water in a high area, but 20% of our energy is pretty good. However, interrupting a river's flow does have its consequences. Obviously, the land behind it gets flooded out. It used to be a river system, and now it's a lake system. So not everything can survive in a lake system when it used to be a river, and we're flooding a large area back behind it. Also, the fertile sediment is building up behind the dam. The sediment, the silt, used to flow downstream, make it all the way down to that delta, right? Well, we build a dam and the sediment builds up back here and it doesn't make it downstream. And a lot of areas used to count on that very fertile, mineral-rich soil making it down there. Dams stop that process. Once again, it's just another ecological problem that dams create. And also, if dams fail, if the dam bursts or break open, the people living downstream can get killed, obviously. If all that water releases at once, which occasionally it does, and as our dams are getting older, dams have like a 50 to 60 year lifespan, and then they have to be majorly reworked. And a lot of our dams in America are coming up on their lifespan, and silt's building up behind them, they're getting weakened, just things we have to look at. Let's talk water conservation, because as we get more and more people in the world, we need more and more water, but there's only so much out there. Now, most of our water is salt water, but we can't drink the salt water. We can't irrigate with the salt water. So we have to make use of the 3% that's fresh, but of the 3% that's fresh, 77% of it trapped in ice, 22% under the ground, and a lot of it underground is way deep underground. So it's this very small amount of surface water and groundwater we can tap into. We need to be conservative. We need to enact some conservation methods. We need to treat the water what it is, liquid gold. It's life, right? Without it, we can't survive. But as water begins to get depleted and we're taking it out of the aquifer, we have to drill deeper wells. As the water table sinks down, because we're pulling more, just like a pump. You pump water out of a fish tank, eventually there's no water left in it. And we can pump water out faster than the rains will bring it in sometimes. So when we're pumping this water out, every new water we have to treat and clean, etc. It's a process and it's expensive. So every bit of water that we can conserve, not use, means water there for somebody else or us at a later time. So we just want to be careful with what we have. So let's talk the big one, agriculture, right? 70% just about of our water is going to agriculture. So we want to make sure that we're doing that in the most water conservative method possible. We want to make sure most of the water is actually getting to the roots. So the drip irrigations or some of these low pressure water systems that are just putting small amounts in, getting to it are very important. Also, don't water your lawn in the middle of the day when it's hot. More of the water evaporates. Do it in the evening or the morning when it can soak into the ground. Just using different irrigation systems can make a big difference. Unfortunately, the disadvantage is they tend to be expensive. Now in industry, for us in America, industry is our biggest use of water supply. And the one that's using the most water are power plants. So we're having to recycle, cool the water, wastewater, but instead of charging it into a nearby river, if we've heated this water up, Well, if we could put that into a nearby business and maybe help them lower their heating costs, if that water is heated up and it's cycled through a pipe through the walls, well, it can warm the walls and help cut down some heating. And in a very innovative program in Denver, they pay small businesses to introduce water conservation measures. Not only saves money for the city and the businesses, but makes more water available for everybody in the area. And this is a great way to use kind of full cost pricing, or it's like subsidies. If you will find a way to use your water more conservative, we'll actually give you a paycheck to make it worth your while to save the water. Because if there's no incentive, a lot of times we just don't care. Now, you and I can save a lot of water by just changing a few everyday habits. Low flow toilets are easy. If you happen to have an old toilet, maybe from the 80s or 90s, it might be time to change that thing. Some of these old toilets can flush 8 gallons at a time, as opposed to the new ones like 1.6. Think about how many times you flush a toilet a day. And that's a lot of wasted water when new technology can use much less. Low flow shower heads. When I shave in the mornings, I don't run the sink the whole time. I put a little bit of water in and then I shave and run it out. When I brush my teeth, I leave the water off while I brush my teeth. I just turn it on to rinse it off. Little things can go a long way. Watering your lawn at night. Ideally, not even using water. Xeriscape your lawn. Make your lawn whatever grows in the area that you live. When I bought my house, there was an irrigation system. I live in a tiny little place. Well, there's an irrigation system. I shut it off. What I do, I cut my grass every other week. The grass grows a little taller, and that makes the roots grow a little deeper. When you cut your grass really short all the time, the roots stay short, and you have to water it more often. I let my grass go a little bit taller. I cut it every other week, and I never have to water it. A simple change. Now, yeah, it took a year for my lawn to adjust to the new patterns, but I never have to water my lawn, and I have a nice looking lawn. Xeriscape it. Now, I'm also in Florida. We get a fair amount of water. Some places in California, they're going to using cactus, native grasses out in their yards. Look around what's actually growing in the world around where you live and make your lawn more native to your area. Cut down on our water use tremendously. Now, in some places, conservation alone isn't going to do it. There's just not enough water there. Desert area, very dry, local sources aren't there. More people coming into the world, cities growing beyond what the water supply can provide. 2 possible solutions in the future. Desalination. There's plenty of water in the world. 97% of it's salt water, and all I got to do is take the salt out. Desalination. This is what the water cycle is doing all the time, right? It evaporates it, dumps it down. Another one we can look at is transporting it, taking the water from here to there. Now, we talked about that with dams, but there's some other ideas as well. First, let's talk desalination, the process of removing salt from ocean water. Once again, this is what the water cycle is doing all the time. It's easy. You and I can do it at home. You boil water, salt water, you catch the steam, you cool off the steam, and you get fresh water, because what evaporates is H2O and the salts and everything remain in the pot. The problem is, it takes energy to boil the water, so the process is expensive. Now, some of the countries and some of the drier parts of the world and some of those with oil money, they're fairly well off in the Middle East, have built a lot of desalination plants. And that's what they do. They're heating the water, collecting the water that evaporates, and reusing it. We have some plants in California as well doing it. Technology is being looked into. It is very promising, but it does come with problems, because what do we do with all the excess salt or the super salty water? We just dump it right back into the ocean. In a nearby area, it can destroy the ecosystem there. So we're left with some problems, but it is very doable and something that we're doing. The main thing is, it's expensive. It makes the water cost a lot more. So currently we're only doing it in areas where we're either quite well off or it's just desperately needed. Another thing is transporting water. We definitely have areas that are water rich. Canada, for instance, incredibly water rich. The United States, Alaska, something like half of all the fresh water in the United States is actually up in Alaska, if you will. But we don't have a real good, easy way to get it down to the continental 48, if you will. In Greece, for instance, they transport it in a giant bag. Take a look. This one's my favorite. It's kind of like a giant Ziploc, if you will. Now, Greece is pretty close to the mainland of Europe. So a tugboat goes over, they fill it with fresh water, and the tugboat pulls it across. They don't have to transport it too far, so this works for them. But not everywhere can really deal with the bag version of it, if you will. And also, we're considering it in the United States, actually, because, you know, from Alaska down to the United States, not real far, and especially Southern California, which is more water dry. Possibility. Now, 77% or so of our Earth's water is frozen in ice caps, and then icebergs break off. Well, icebergs are fresh water. And we've toyed with the idea of grabbing an iceberg and towing it somewhere that needs water. We just haven't come with an efficient way to do it. Because by the time you tow it somewhere where it's melting along the way, because most places that need it are farther south where it's warmer, and the ice is melting, and then you just have all the gas that you're having to pay for the tow truck to take it down there. So towing icebergs is an idea. There's a lot of fresh water trapped in the ice. We just haven't come up with a good way to do it. Maybe you will come up with an idea